Good afternoon and welcome to this talk about LLMs. My name is Sergio. I live in the UK, although I was born in Spain. What? Stop it. And sorry, I lost my train of thought. I lived in the UK. I grew up in Spain, and I work for a company called Digitalis. And Digitalis, we are a managed services company. We do deployments of any sort of applications for customers, from databases to Kubernetes, and of course, LLMs as well. So what we're going to be talking about today, we're going to be talking about why we think there's a need to deploy LLMs internally on private networks. I'm going to argue the case against pro and against doing those. And also, we're going to talk about, especially, and this is not a talk about creating LLM. This is a talk about maintaining and supporting LLM with DevOps techniques. I will be talking a lot about LLMs as well, but most of the things that I learned from my developers in the team, not another developer myself. So I'm going to cover all the different aspects of why we need to deploy LLM and how we do it. So why? The main reason for it is around security. So there's been quite interesting talks in the last couple of days in here at DevOps and Look DevOps. People using all sorts of AIs to improve their development skills, to speed up their company processes. There hasn't been a lot of talk about security and privacy. And that's one of the things that we believe is one of the most important categories for us to why we need to create and deploy internal LLM. Another thing is that your data is your data. The data is very important, so don't share it too much. You don't want to share your IPs, your intellectual properties with other companies. It's yours for you to use. And one of the most case scenarios we get, it's air-gap environments. So we work with a lot of banks and financial institutions that don't allow connectivity to the internet. So forget about using ChatGPT, Gemini, or any of those. That's not going to work. So that's why we need to deploy an internal LLM for them to use. What the downsides of using internal LLM is not cheap. It depends what you're doing. If you're doing a rack augmentation or a fine-tuning, it could be from a few $1,000s to a few millions, depending how much information you're actually deploying and tuning. So this is really the biggest downside of deploying your own LLM. Other things that you should consider is that obviously there is a management overhead. So you've got to deploy, you've got to run it, you're going to support it, you're going to fix it when it breaks. So that's a big downside. Let's talk a bit more about privacy and security. Most companies, especially in regulated sectors, they have an issue with privacy and security. So imagine I'm sure you've done it, all of you done it, copy and paste some question into ChatGPT without realizing you're copying in data from your own company, even customer data like username and password or name on address or date of birth, things like that. That's security compromise on your data. You shouldn't be doing that. Your data is your data, and your customer data is your customer data. There is a lot of regulations they're gonna you're breaking by doing that, and most of us don't realize. There is very little privacy also on this host, and I can't see my own slides, so I'm moving here. There is the public LLMs. They're not here for you. They're going to make money. If they're going to make money out of your own data, so your data is their gold. Things that I found when doing my own research, things like some of those LLMs, they actually copy and access your clipboard when you copy data. So you think you're not sharing anything, and then suddenly you copy a username and password. You're going to ask a question to ChatGPT, and it knows the username and password you just copied in. So yeah, the data security, it's hard to come by, hard to implement, and the data you're giving away is the money you're giving away. And of course, you're breaking, there's lots of regulations. Here in Europe, GDPR is possibly the most well-known. And you haven't had any training on what the GDPR means is that any data, customer data you are misusing is a violation. And the penalties are really, really high. What happens if you don't pay attention to your data? You could be fined, of course. That can be a lot of money. A bank could get fined by millions and millions of dollars just for a violation of GDPR. You can have privacy whatsoever. So privacy absolutely paramount. And so when using external public LLMs, you're not getting that. I'll give you a really good case scenario. That's something I like to use on my talks. All of you possibly have a CV, a resume is being applying for jobs. You may not realize that all the recruitment agencies nowadays pre-process all the candidates with AI. So your personal data, your name, your address, your date of birth, all your company history is being fed into a AI model. And the AI model, if it's a public LLM model like ChatGPT or Gemini or those, your data is being possibly stored by them. So be careful with what you share. Now, okay, so let's move on from privacy. Let's come to the conclusion that we do need to deploy our own internal LLMs. Where do we do that? We need to host it somewhere. Data hosting is as important as sharing the data with an LLM model. So your data is in a region like the United States, for example. They have really, the privacy models is not very strict. You're likely, again, sharing your own data with those companies. So what you should do is stay on a compliant region. If you are a European-based company, stay within European data center. Okay, let's go on and design our own LLMs. So what do we need? So we need to understand what we want to achieve. Do we want just to create a simple chat for our customers, our internal customers or our colleagues to use? Do we want to do a bit more complex, like an agent? Where are we going to host it? It's going to be, can we go into the cloud, or it's going to be on premises? Do we have GPUs to deploy it? Can we grow those GPUs when required? Which sorts of LLM are we going to be using? There's a lot of questions to answer. I love those diagrams. That's created by AI, and some of them are actually fantastic. Anyways, GPUs. You're going to need GPUs. There's no question about it. You're going to need GPUs to both train your LLM if you're going to train it and to run it. That's going to generate some data. It's going to use and generate data, and you need to store that data on a place where it's viable for your company. Like I was saying before, if you're a European company, you may want to use a European data center. Are you going to train your LLM? If you are going to train your LLM, you're going to need ancillary servers. You're going to need your own database for the RAG augmentation. You're going to need all the monitoring stuff. You're going to need your chat UI. You're going to do it. You're going to do your deployment strategy, your CI/CDs. Let's go for the most simplistic version of an LLM. So let's say you want to deploy your own LLM on your own company. You don't care about training it, and you're happy to use an external publicly available model like a Llama 3. All you need is some GPU servers, a web UI, and a load balancer to access the LLM. The GPU servers, more or less easy to combine now. In most data centers will provide you some GPUs. For web, you can create your own in-house web server for the chat service, or you can use one of the many available open. My favorite is the Open Web UI, which is really good. So that's what it look like. You just get a front end on Open Web UI. Or Llama is really simple to use. It doesn't require any configuration, so a bit of parameter changes. And decide to use a model like a Llama. And this in the screenshot, I got it up and running in 5 minutes. It's there for me to use. This is not enough, so I'm gonna expand a little further. We want to, the issue with Llama is not very well geared for large deployments. So once you got more than 2 or 3 users, you're gonna struggle. So let's scale it up a little bit. Let's go up with we can still retain the Open Web UI, but instead for Llama now, we're gonna be using either VLLM or Llama CCP. And the model, again, you can choose any of the available open source models. So that will give us more growth, especially with VLLM. You are able to run more queries from users than with the others. And also the good thing about VLLM is ChatGPT compatible. It means that any of the applications that work with ChatGPT, it should also work with VLLM, like the Open Web UI. Moving forward, we're going into the most complex of them all now. So we have our own data. We need to train the LLM with our own data to be able to query it. So we need, again, a web UI, your Llama VLLM or Llama CCP in our case. And now it's getting a bit more complex. We're going to need some servers where to train the models. You cannot, because those LLMs software consumes so much CPU, you are unlikely to support training at the same time as using. So you're going to differentiate. Yeah? You're going to need some GPUs for training and some GPUs for daily use. So you've got some training servers. You're going to need a vector search database. You're going to be storing all the data learned through your AIs. And obviously, you want to protect your data with authentication, with you're going to configure limits and how much a user can use the models. You're going to need also a user database for the storing some additional configurations. And the last bit is a queue server, and that's something I will speak more a little bit further down. Okay, so we've done the initial information gathering. Now let's get into the more in-depth configuration. So what do we need? Once you get your GPUs, depending which ones they are, if they're NVIDIA or others, you're going to need some drivers and install those drivers. The thing with the drivers, especially with the NVIDIA ones, they can be quite difficult to configure sometimes. It's surprising that upgrading the drivers can easily turn off your own servers because they don't upgrade finely. They're not fine-tuned for running on servers. Some of them, especially some of those versions. So you need a way to deploy them consistently on the different hardware and to manage them. So we're gonna choose carefully. The second thing is you're gonna be running a lot of data. Data that is, as I was explaining before, is very private. So you gotta be careful with where your data is stored, and your data is only secured. So ensure you got a recent OS version and is properly configured and hardened. The last question you may ask is, should I use containers? You can. There are some advantages using containers for running your software, but also some disadvantages I'm gonna run through. Because we're not talking about a simple LLM, just or Llama and a web server, we need a way to managing all the components we're going to be deploying, from the databases to the web services and the GPU servers, the drivers. So that's why we use a combination of Ansible and Terraform. Ansible is for managing the software itself, managing the installation of the servers, the drivers, and Terraform for the infrastructure and Kubernetes. I'll come to Kubernetes in a second as well. Once your software is deployed, you need a way to manage the life cycle of the software. So you got the developer creating the authentication layer or creating the web UI or the different components. You want to give them the ability to deploy new versions without user interaction. So GitOps is perfect for it. So you use, I favored Argo CD, but Flux CD is as good. So Argo CD to get your GitOps in place and managing the different software. And finally, you also need some CI/CD pipelines. So you're going to be creating some software, like I was saying, for example, is the web chat UI, and your developers are going to need a way to build that UI and ship it to the GitOps. So you need pipelines. We're talking about you're going to be training your own LLM model using RAG in this case. So you need a database. There are several candidates out there, all are pretty good. So we went through the most of them, we tested most of them, and we acknowledge the different pros and cons. pgvector from Postgres is very good, very powerful. It has some issues with the scaling up. So if you remember how the Postgres model is primary and replicas. So your primary is going to be requiring a lot of writes. You may struggle to grow it. But if you're going to need a lot of reads instead, you're probably going to be fine. Just use many replicas. Cassandra is another available option. The thing with Cassandra is that, unfortunately, only came out a few months ago. It's not battle-hardened. As much as I like Cassandra, I chose against using it just because it needs more testing. I think it needs a bit more time debuting before we commit to using Cassandra for this. I think Cassandra is great. And the last one we looked at is Milbus. And Milbus, the great thing about Milbus is that it's purposely built for LLMs. So it's a bit complex to configure and deploy, especially when you use the full version rather than the standard. So let me rephrase that. There are two versions: a standalone and the full version. The full version is quite complex because it requires queues, requires GPU nodes, requires quite a few things. The standalone version is just a simple binary. It's easy to deploy. So you look at just the standalone version is actually really simple to deploy, and it's very good. It's very powerful, very fast, and for us it was the winner. The next thing is to let's select a software to use between Llama CCP or Llama and VLLM. Llama is the first one you can discard quite easily. The issue is that with Llama, it's designed for desktop users. So it's designed for you to run on your own laptop. It's not designed for a server. It has issues with concurrency. So when you just send multiple queries or multiple questions or multiple requests to Llama, you will break it in no time at all. Llama CCP and VLLM, they're those equally good. And they're both really fast, very powerful. And even their code is not dissimilar, so you could easily use Llama CCP, migrate to VLLM in no time. The one thing I like more about VLLM over Llama CCP is the clustering, the way they do distributed inference. VLLM, I think, is slightly superior to Llama CCP. So that could be a consideration for you when you deploy it. If you think you're going to need multiple you're going to be using large LLM models with inference, choose VLLM instead. There are loads of open source models you can use. I just selected a few, the most well-known. But the most important part for selecting a model is size. between 7 and 8 billions, it's more than enough for most companies, for most people training their own data. They will give you a good balance between not too many hallucinations and able to process your data and record it and obtain it easily. There is another way of doing it. You, instead of using a RAG, you define to fine-tune your own model. You could use one of these specialized models. Specialized models are things like, let's say that your company deals only with maths. You could find a specialized model that knows nothing about coding, but is great at maths. Those models are much smaller. They fit better on GPU's memory, but they're not generic. They don't have the answers to everything, just something really specific for you. Also, they have a tendency to hallucinate more, but still, it's worth considering. Would you expect to be able to run on a medium-sized model like 7 or 8 billion? You're not expected to be able to query the LLM with more than 2 or 3 concurrent times. So that's one of the biggest drawbacks of using your own models, is that you think about it, the model is loaded into memory. If you've got a GPU with 20 gigs of memory, but your model is 20 gigs, one query is more or less what you'll be able to do. 2, if you do a proper tuning, maybe even squeezes up to 3, with the risk of hallucinations. So choosing a small model that will do you well is very important, because that will means you don't need to use as many GPUs, and therefore it's cheaper. So let's explain a little bit more how it works. So you've got a model. Again, let's say there's 10 gigs in size, and your GPU is 20 gigs. Every time you query the model, it loads into memory, and uses 10 gigs, and that's the amount of memory you can use. If your model is 30 gigs in size instead, but your GPU is only 20, you've got 2 options. You can add a second GPU to the server, and that case it creates layers. And each of those layers is resolved by one of the GPUs. So your model is basically, you're assuming adding up all the memory. If you got 2 GPUs of 20 megs each, you'll be able to run up to 4. It gets to a point where you don't have enough GPUs on your server. Your memory requirements, let's think a big model like DeepSeek, sorry, the Chinese one. The DeepSeek model is 30 gigs. So you need 2 GPUs at least to be able to run this model. And that will give you 2 concurrent, up to 4 concurrent queries, which is not a lot. So what you do is you create a large pool of GPUs servers, and then you use distributed inference. What it means is that when you ask a question, the model is going to spread through the different layers to different available GPUs, up to make sure that they all fit, and it'll use a cluster of GPUs to answer your queries. That gives you a lot more growth than using a single server with multiple GPUs, with the penalty of network. This is very network hungry, so you need fast networks to be able to communicate between GPU servers. Otherwise, you can experience a long delay in getting the answer back. When I was saying before about selecting between VLLM and Llama CCP, in this, I think VLLM is a little bit better with the way they do this distributed inference. Okay. I said already multiple times that with a model, you can only run as many queries as your memory. So what happens if you don't have enough memory? You see the screenshot? It breaks. The query is held into the model, and until it's available the GPU, it won't answer it. So it means that you can DDoS your own LLM model very, very easily. Just create a simple cal command with send 4 or 5 requests to the LLM model with nothing in the middle, and you will break it. I think this screenshot is from Olama. I think it's from Olama. So what our solution for it? It will create the queues. So we're running RabbitMQ servers in the platform. And what it means is that we can create one consumer per GPU. That's assuming that, I'm assuming for this you can only run one query per GPU. So one consumer per GPU, therefore it never locks. The worst that can happen is all the queries are queued for a long time until it gets resolved, but you're never going to break the GPU because there's not enough resources. Obviously, if you have multiple GPUs on your server, you can multiple consumers. And with multiple consumers, you can answer more queries at the same time. Or if your model is well-tuned and you are able to answer multiple queries from a single GPU, again, you can run multiple consumers. So each consumer will be to deal with a question and answer. Let's talk about containers. I love containers. I use containers for everything except for LLMs. Why? Because they're heavy. They're really, really heavy. The software required to run LLM, as you can see in the screenshot, it can go from easily 6 gigs, and that's only the software. That's only the libraries. That's not even adding up the LLM itself. With LLM itself will be between 8 and 30 gigs. So imagine having to run those on Kubernetes and do a long pull to get your container down and running. So it means that every time you got a failure on your Kubernetes cluster, it's a long wait for the pods to starting up again. There are multiple techniques it can be used to improve that. You could put your libraries in your host. You can use shared volumes. Still, I don't think it's worth paying. Maybe in the future, but not right now. The other thing with containers is that it's not huge, but there is a penalty on memory and CPU and network bandwidth. They won't be as fast as running on bare metal or on VM. Okay, so the something that is often really overlooked is the storage. Those models, the LLM models suffer from a cold start issue. What it means is that when you start up the model, when you start out your software, it has to load the model into memory. If you think about your model is maybe 30 gigs, it's reading 30 gigs from disk to loading into memory. If your storage is slow, prepare to wait. It's a long wait to get your model loaded. If you get, let's say you got an issue with your application is restarting or is crashing, you end up loading the model multiple times from a slow storage. So what I'm finding is cloud providers like Google, Amazon, Azure, all of those, they usually provide quite slow storage. So you're going to struggle with large models in the cloud. That's why we tend to prefer bare metal for this. The SSD is a lot faster than anything you can get on cloud. Okay, we've got something already. So we've done the partial design of our model. So we have the queues with everything queue, our web UI, and Milbus for the data we're going to be training the rack with. And in bare metal, we have our GPU servers, a cluster of GPU servers. They're going to be driven by the RabbitMQ consumers. The most important thing is it's the network. I was saying before, you need fast networks between all the components. It's more so with the GPU servers. And we're using a combination of Kubernetes clusters and bare metal. Kubernetes is really handy to run all the software, like the web UIs and the consumers and things like that. Sorry, not the consumers, and the RabbitMQ servers. And you can leverage all the RabbitMQ consumers, which are the LLM software, into the bare metal for faster loading times and answering questions. So I've got our dedicated GPUs we're going to be using for training the models. Those are the ones that are going to be reading all the internal data or any data you want to train the models with. the RabbitMQ, they're going to be the consumers going to be answering all the people's questions. Mailbus has the selected rack database, and also we need some GPU nodes to actually run the model itself. So remember that when you're training the model, you're going to be using your GPUs, and you won't be able to use the same nodes for queries. Oh, I forgot about that. That's what it looks like. For monitoring, we don't want to stick with the well-known Prometheus and Grafana. It's just easy for us to use. Everyone knows about them. And we also need a small database which is going to be storing all the all the user's data. So let's say that I ask a question, and the question is going to be recorded on my web UI. I'm going to see the history of the questions I ask. That sort of thing is going to be stored into the database, as well as user configuration, limits, and things I'm going to be talking about. The incoming requests, they need to be really limited. I will talk about it in a second. So that's why we need also an API gateway to make sure that we're not overloading the models with too many queries. And developers love telemetry, so put some telemetry in place for them to be able to debug the application when something fails. I forgot about that one as well. Okay, let's start training. So what training means? Training means getting a bunch of PDFs, essentially, and fit into a training model and storing all the resulting data into a database, vector search database. So what are the steps? Simple, just get a crawler, get something that pulls your data. If you want to get data from your company internal websites, you need a web crawler. If you want to get your data from your company Word documents, get something that converts the Word documents into PDFs. So that's what the crawler will do. It amalgamates all the data into an easy place for the training to occur. We found the PDFs is the PDFs and TXT are the ones that work the best for training. But you can actually, in fact, use Word documents if you want, even Excel. But I don't recommend it. I think it's PDF and TXT is the best. Oops. Once you get your data trained, it's gonna send over to the vector search database. It's gonna get stored there, and that's gonna retrieve. And when you ask a question, you're gonna get the answer from that database. Now, this process, you're likely to run it frequently, depending on your internal needs. Let's say you want to. A good example is a call center. It's something the call centers are implementing. All of them are implementing LLM models nowadays. So what it means that you ask a question to your call center, a support question, and you get the question and the answer. So every new day, there is more data being generated, questions and answers from customers, and search and advisors replying to the questions. So that data is invaluable for them, because next day your AI model will be to answer the question automatically. So you need something that is able to process all the data every day and push that again to your database. The thing with that's what you make the training in stages, so you can break it apart. In something fails, repeat the process again. The training can take a long time, so you don't want to waste time in breakers. So if something fails, make sure you're able to retrace the steps and redo it again without having to do the whole thing. One thing we do for our own data is that we create, in the case of Mailbus, and it's the same thing for Cassandra or pgvector, you basically create a new database every day. So you see the middle line, the Mailbus collection, that is the data that's been generated for that day. And so we can roll over training data, and every day you're using more up-to-date data on your searches. Let's get implementing. Okay, so assuming you're going to be starting with a OSS model, so one of the openly distributed models, and you can get from the internet. So Hugging Face is the perfect place to get them. There are loads in there. They're really good. Not all of them. There are many good models. So you're gonna get hold of one of those. Be mindful of the size. It's unlikely you're going to be running a single model. Often you have more than one model. So expect to reserve a large amount of memory, disk memory meant, disk space for the models to be stored. Also, you're going to be updating the model frequently, so you need to be able to roll back and roll forward. So keep that in mind. You need a lot of disk space. Make sure the disks are really fast. I was saying before, the cold start is a pain. Just look at the screenshot, the top. So a simple 8 gigs model takes 3 seconds to load. That's a long time. It should be loading much faster, and that's on bare metal. So if you do the same comparison on AWS EBS modules volumes, it's probably 3 times longer. And that's a small model. So that's why don't use NFS or anything like that. Ignore all the share network file systems. They're far too slow for any model. The one thing that once you decide to use Llama CCP or VLLM, one thing to remember is they don't support, they're not compiled by default with GPU support. So make sure you get it is available for your GPU, the binary distribution. And if it's not available, compile it yourself. It's amazing how many people forget this simple step. And especially Llama CCP is very forgiving. Llama CCP will run on CPU just fine. So maybe sometimes you don't know you're actually running on CPU, and you think you're on GPU just because you forgot to compile it. Those drivers, Llama CCP and VLLM, are very fast evolving. You will probably find a new version every week of them, and sometimes are not incompatible with the previous version. So it's important that you keep them in virtual environments in Python, and make sure you roll forward with the versions. So don't test it thoroughly and you test environments. Make sure you're not breaking anything. New VM virtual environment and deploy. If something breaks, you can roll back to your old virtual environment. And we're saying in our design elements, we have a Kubernetes cluster as well on top of all the GPU nodes. So the Kubernetes cluster is the one that runs anything that doesn't require a GPU. So all the monitoring stuff, the Argo CD for the CI/CD, the websites for the front end for the users. So all of those components are deployed into Kubernetes, and we favored internally Terraform and Helm charts for it. So we deployed all the components into Kubernetes in Terraform. If you use, if you're going to be using a cloud provider with managed Kubernetes, you probably want to use Terraform as well. If you're on premises, Ansible is great for setting up and installing Kubernetes itself. And Kubespray is the preferred way for us. Should you use on-prem, cloud, or hybrid? Personally, I'm really biased on-prem. The thing with, well, actually, that's actually misleading what I just said. It's not on-prem what I meant to say. It probably meant bare metal more than anything else. So the thing with the cloud is very expensive, horrendously expensive. So I try to avoid it. So you're paying 3-4 times more than any other environment. So if obviously your company is what it uses and you've got no other option, what can you do? But if you can avoid it, use either on-premises or bare metal. So look for there are lots of small providers in Europe. They will give you bare metal servers for peanuts and way faster than anything you can get in the cloud. Remember if you can manage the host yourself, if you're not using managed services, remember to build out the OS properly with all the OS tunings and hardening for security. And if you're managing your own Kubernetes again, you can use Terraform, Ansible, or if you're really lazy, Rancher. You need GPU drivers on all the GPU's servers, and it might sound easy, but actually they're very temperamental. So make sure you get a proper Ansible playbook to install the GPU drivers if you're on bare metal or VMs. If you're on Kubernetes, the NVIDIA operator surprisingly works very well. Obviously, if you're not on NVIDIA, find another way. Anything that is on Kubernetes, Helm charts, easier to version, easier to deploy. Avoid using GitOps for the core components. That's something I learned the hard way. So GitOps is fantastic for your software, like your websites, your APIs. Is not good for anything that is fully very core on your infrastructure like drivers. When GitOps goes wrong, and I've seen GitOps going wrong many times, when GitOps goes wrong, it may delete everything. So ensure that your core infrastructure is there, is sound, it's not moving very fast, and then use GitOps for the rest. So there was a good talk, I think it was on KubeCon last year or 2 years ago, a company that uses GitOps, and they clicked the wrong checkbox in Argo CD, and they destroyed the whole platform for 3 days. So that's why it's very important to keep your core infrastructure outside of GitOps as much as you like it, and use GitOps for the applications. Sorry, just said, just use your GitOps for applications and let your developers deal with them. Okay, so getting there now. We've got what's the time? Oops, no. We get the first candidate for our deployment. So we have all the different components ready to use for our web and question and answering service. So with a web UI, you can pick up all the customer queries, gonna process those, get the answer from the database, and pop's your uncle. Okay, let's look into things that could go wrong. Prompts. I love that screenshot because that it's what happens when you don't define your prompts properly. So when you create the prompts, you have to be very careful how to guide the output of your LLMs to ensure that they're only answering the questions relevant to your organization. So if you've got, you cannot get your internal LLM getting food recipes out. You need to make sure that they only answer the questions relevant. And also you have to make sure that a clever person can use techniques to extract data from your LLM. That's what's called the prompt leaking or data exfiltration. It's using prompts cleverly crafted to get information from the LLM. And the first few releases of ChatGPT, I actually remember, you could ask ChatGPT to disclose their own prompt with a cleverly crafted query. And that was they fixed that very quickly, but that happens even to the best. When you use a proper prompt, that's what you get. So the LLM will refuse to answer the question because it's not part of the information that it knows. The other thing is that you got to control your users. There are developers, especially, they're the worst. So how to make sure that you keep a close look into profanity and swearing. There are many techniques to doing this. You can ask the LLM not to reply with swearing words. You can ask the LLM to say if anyone gives you a swearing word, refuse to answer, and that works. That's part of the prompt. The trouble with using that technique is that you're using GPU cycles to a person that just said a swear word. So it's better to filter them before you get into the GPU. Because every time if someone gets into it and starts saying fuck, no one's gonna get any answer back until all those facts are reply back. If you use something that will quickly from the web browser itself says no, you cannot do that, you're saving a lot of time in cycles. And that's why also you need to implement some limits. You don't want a single person or a group of persons DDoSing your LLMs. So make sure that's why we're using the RabbitMQ queues to enforce rate limits, but also rate limits are enforced on the API itself. So when I was discussing before about this user database where we store the chat history and other settings, there we also store limits. So if a person has answered, let's say, the same query 3 times in a minute, you said no, wait another 5 minutes before asking again. And that gives you more control. Check everything twice, checking the web browser, checking the API, because people are really clever and they will try to get away with breaking the limits. Stop it. When you're in the development phase, it's very important to get a view of all your progress and everything that works and everything that doesn't work, and the breaks and fixes. So we found using Phoenix to be a particularly help. So Phoenix provides you OpenTelemetry-like information on your models. So if you ask, using the example of the chat model, just get a question, something broke down the path, you can get into Phoenix, drill down through the question, and we see exactly what it broke, and you get it fixed. So heavily recommend Phoenix. The other part of the monitoring, and we've got a lot of components in here. We have a Kubernetes cluster, we're running lots of things, and we have bare metal servers running other bits. So we need to make sure that everything is monitored for breakage. Prometheus and Grafana, well-known and well-tested applications for monitoring. So we get those installed as part of the Kubernetes cluster. And we also use Grafana Alloy for monitoring the information between the bare metal nodes and Kubernetes itself. So bare metal will send all the metrics and alerts to Prometheus and running Kubernetes. The NVIDIA exporter is good. It gives you good insights into your NVIDIA GPUs. If you're not using NVIDIA, I'm sure there are things similar. I didn't drill much into it. And again, Grafana Loki for your logs. We need to come into the end. So a couple of things we're going to be improving in the near future. It's as the models are growing quicker and quicker, having a single GPU server with several GPUs is no longer enough. So we're going to have to start really implementing distributed inference. So that's why we move into VLLM. The alternative with Llama CCP is not bad either. They're using the RPC. The RPC works similar to the VLLM, whereas you send a request to a host and that spreads the request to multiple nodes by RPC protocol, and they get the answer through. The answer gets answered by multiple nodes at the same time. The array on VLM is slightly better, more advanced. It's been out there for longer. The downside is the VLM does not support as much hardware as Llama CCP does. So there is a bit of compromise in there. So we decide to use fully with the LLM, we're going to be more strict with the hardware we choose. If we use Llama CCP, we can be more flexible and have other hardware options. And coming to the end, the worst part, if I can say that, for the AI is that it changes daily. It's unrelentless. It's really difficult to keep pace. Things that I was doing 6 months ago are no longer valid. And you wouldn't do them like that anymore. So yeah, that's hard to keep up. The models are going bigger and bigger. So I was saying inference is just not a question of when, but you're gonna have to get inference. The good thing is against using inference is they're coming up more and more small, heavily specialized models. Because they are much smaller, you're able to run more than a single GPU. So that's perhaps is the way to go forward. Is forget about knowing all from a single model and use multiple small, heavily specialized models. And remember that privacy is here to stay. Don't share your data with the enemy. Don't be careful with that. All the regulations that are in place to control your data sharing, and make sure you know your organization is not breaking the law, because the penalties are really high, really steep. And just to make clear, just because this is recorded, and I'll finish my talk here. Thank you. If you got any questions?
I have actually 3.
Of course.
The first one, have you used or do you use a caching solution for the deployments? That's the one. And what is your preferred way of controlling the entire workload? Because now I only see the Kubernetes as a control plane or maybe RAID cluster, but there are other control options I see around. Do you have an opinion on that? And the last one is, what is your preferred rollout strategy when you deploy?
So the last question was?
Rollout strategy.
Rollout strategy. Okay. Yeah. So start with the last one. The rollout strategy, and because we're using Ansible and Terraform, we can do one-by-one servers. So we roll out a new model, and then we start the API servers on that model, on that server, and then continue one by one. So we have to keep backwards compatible API at all times, otherwise it would break the model, but we can do one server at a time.
Control plane and cache.
The caching you mean for the question answers or for the
computer results from the GPU servers?
Not right now, but we've been looking at using the RAW augmentation for also caching. So there is a nice project, I forget the name now. There's a nice project they will do you that. So you can store your questions and answers, retrain your model with those, and then we'll use the vector search to pick up the answer that's already being answered. But we're not implemented it yet. Control plane for RAID clusters, you mean?
For the GPU servers, actually, for several reasons. One of them is being like optimization of results, reusage or redirection of the loads, like better load balancer.
Oh, you mean like what's the name? Paddle, similar things like Paddle. No, because we're using the RabbitMQ queues, we have no requirement for Paddle. We looked into it, but I think the queue model for us worked better. Because you would use Paddle, you still need array limiting somewhere, because Paddle is only going to spread the load through. Whereas we pick up the questions and answers from the backend using a queue, there's only one at a time.